Assalamualaikum warahmatullahi wabarakatuh. Welcome to the fourth video lesson for physics online learning. So for this week, we will finally start with a new unit or a new chapter, which is chapter number 4 or unit number 4, which is called dynamics. In this unit, we will look at forces. So last time, unit 2 or chapter 2, we looked at kinematics, which in that unit, we look at the study of motion. So what is motion? What is speed, velocity, acceleration? How do we describe motion? How do we show the motion of an object using numbers? For example, 50 meters per second, 2 meters per second square. We can also show motion using graphs. So we learn a bit about graphs. And also we looked at the motion of free-falling objects. So we talked a bit about free-falling as well. In this topic, we will look at forces. Now, you can think of forces as the cause of motion. So when something is moving or something is stopping, usually what is causing that movement or what is causing an object to stop is a force. So you can think of this topic as the causes or the effect or the causes to motion. So dynamics, we will look at the forces and their effect on motion. Let's look at the basics of forces first. So what is a force? A force is a push or pull that can change the motion of objects. What can forces do? Forces can change the speed of the object, can change the direction of the object, can change the shape of the object. Let's say you have Play-Doh. What you can do is you can push the Play-Doh and then it can change the shape of the Play-Doh. That's an example. And generally, forces can change the motion and shape of the object. So that's the idea here. What's the unit of a force? The unit of a force is Newton. And the symbol for this unit is capital N. So make sure when you write down the unit of a force, make sure you have a capital N and not a small n, because a small n means a different thing. You can measure force using a spring balance or Newton balance. So probably you have seen this before when you were in year 7 or year 8. And these are some of the examples of the types of forces that we have in the world. So you have encountered the first one before. So when objects fall, they always fall to the ground. This force that pulls them to the ground is given by gravity, and it is known as weight. So gravity is also known as gravitational force, and also it's known as weight. So when we talk about weight, we are talking about the gravitational force on the object or the gravity on the object. When a rocket lifts up into the air, it gives out a large amount of force to move up. This force is called thrust. When you have two magnets together, when two magnets are attracted or repelled by each other, this is called a magnetic force. And the force inside a rope, so if you have a rope and then you pull it, or if you have a spring, or if you have a string, any type of like rope objects, if you pull it, the force inside, that's what we call tension. That's the tension force. There are a lot of different kinds of forces. These are just some of the examples, but that's the thing that you need to know. There are a lot of different kinds of forces. Now, there are a lot of different kinds of forces, and these forces can all act on one object. So if you have a force going up, a force going down, you can add up all those forces together, and then that will result in something that is what we call a resultant force. So if there are several forces acting on an object, we can add all the forces and we can get the resultant force, or otherwise known as the net force. So if you have several objects acting on several forces acting on one object, you can add all of them up and make them think of them as one force, and this force is called the resultant force. The resultant force has the same effect as each of the added forces combined. So as you can see in this first picture here, you have a force going up and a force going to the to the right, and this will have the same effect as having one resultant force that is pointing northeast. So The resultant force is the combined effect of all the forces acting on the object. Number 3, if the forces acting on the object is unbalanced, there is a resultant force or a net force. So like in this example here, so you have a force upwards and to the right, combine them two together, it will look like to have a net, it has a net force that is going to the top right, like this one here. However, if the forces acting on an object is balanced, the resultant force or net force is 0. So for example, in this box at the bottom here, the force upwards, let's say the force upwards and the force downwards, they are both equal. So that means they are pulling or pushing each other at equal strength. So when you combine these two effects, basically the effect is cancelled out. So the box doesn't go up, the box doesn't go down, the box doesn't go anywhere. So there is no net force. So when it comes to forces acting together, you can have them unbalanced. So if you have an unbalanced force, that will eventually produce a resultant force. If the forces acting on the object are balanced, then there are no net force, or the forces cancel out each other. There's no resultant force. So let's do this exercise very quickly to see what I mean. So the first one here, you have 9 Newton to the left, and then 4 Newton to the right, and then 5 Newton also to the right. These two together is, when you add them together, it will produce so the total forces on the right side of this box, that is equal to 9 Newton. And you have a force of 9 Newton to the left, and then a total force of 9 Newton to the right, and these two forces will cancel out each other. So 9 Newton minus 9 Newton, that is equal to 0 Newton, right? So there's no net force. There's no net force because the two forces, all the forces acting on this object are balanced. For example B, you have 7 Newton on the left side pushing to the left, and then you have 3 Newton pushing to the right, 6 Newton pushing to the right. If you add these two forces together, that is equivalent to having a 9 Newton force to the right. Now, because you have a stronger force to the right, a stronger total force, which is equivalent to 9 Newton, and then there's only 7 Newton to the left, a weaker force. So the resultant force will be 9 minus 7 Newton, and then you will have 3 Newtons. So the resultant force is 3 Newtons. The resultant force, so the resultant force is 3 Newtons to the right. Okay, that's the resultant force. In this case, the forces are unbalanced, and when forces are unbalanced, it will produce a resultant force. In this case, it's 3 Newton to the right. For example C, you have 7 and 5 Newtons acting to the left. So the total of these two, 7 plus 5, that's 12 Newton to the left. And then 6 plus 6 to the right. So the total of that is also 12 Newton. And you have a total force to the left that is 12 and a total force to the right that is 12. And these two forces will cancel out each other because they are both the same strength or the same magnitude. So they will cancel out each other. 12 minus 12. So the resultant force will be 0. So the net effect, there's no net effect. There's no net force, 0. And so from this, we can tell that the forces are balanced. They cancel out each other for C. For D, let's look at D this time. You have 9 Newton and 5 Newton to the left, and that will be equal to 9 plus 5 is 14. 14 Newton to the left, and then for forces acting on the right, 6 plus 7, that is 6 plus 7, that is 13. So 14 newtons to the left, 13 newtons to the right. The left force is stronger, so the left force will win. So you will expect to have a resultant force that is pointing to the left. So, and the magnitude of this left resultant force is 14 minus 13. That is equivalent 1 Newton to the left. Okay, so the resultant force, or otherwise known as the net force, is 1 Newton to the left. And are these forces balanced or unbalanced? So these forces are unbalanced because they produce a net force. Let's talk about how forces affect motion for this slide. Greek philosopher Aristotle thought that motion was maintained by forces, and when there is no force, the object will stop. So a long, long time ago, there's this philosopher called Aristotle, and this philosopher said that if you don't have any motion, you will not move. Is that true or not? We will see. So let's look at a situation where you throw a ball. Once you have thrown the ball, your hand is no longer in contact with the ball. There is no force acting on it, yet it still carries on moving. So when you are throwing a ball upwards, let's say this is a ball with my hand here. When you throw the ball upwards, when you throw it upwards, when it's in the air, the ball is no longer in contact with your hand. While it's with your hand, it will experience a force upwards. So but as soon as you let go of the ball's in the air, it's no longer in contact with your hand. It's there's no force on it, but it's still moving. So in other words, Aristotle was wrong. Even though even in the real world, even though there's no force acting on the ball, especially when it's in the air, it's still moving. The situation above shows that Aristotle's explanation is incorrect. And then 2000 years later, a scientist called Galileo Galilei realized Aristotle's explanation was wrong and worked on ways to describe motion better. And then a couple of hundred years later, Isaac Newton, or a couple of years later, Isaac Newton then took Galileo's work and then created 3 simple rules governing the motion of objects. And these rules are called Newton's laws of motion. So basically what this story is talking about, the story is talking about what causes motion. Does force causes motion? At first Aristotle thought that, okay, so you need a force. So force causes motion. So if you don't have a force, so there will be no motion. But that is not true. Even though sometimes in some situations, for example, like the ball, throwing a ball after the ball has left your hand and it's in the air, there is actually no force acting on the ball, but it's still moving. So Aristotle was wrong. And there is something else going on here. It sometimes even when there is no force, there is still motion. So there's a lot more things going on than what Aristotle believed. And the explanation comes in these Newton's laws of motion. So Newton and also Galileo, they figured together. So Galileo figured it out first, but then Newton refined it further, and together they figured out what are the laws or what are the things that causes motion. So we will look at these 3 laws in this lesson, next, and also in next week, in the next video lesson. The first law of motion states that, so this is very long. This is a very long statement. So the first law of motion states that an object at rest will remain at rest, and an object in motion will continue in motion at constant speed in a straight line if there is no resultant force acting on it. Right, so let me just explain, let me just break down the parts to the statement and explain what it's talking about. This statement, the first law, is talking about when there is no resultant force, when there is no force acting on the object. If there is no resultant force, or there is no force acting on the object, what will happen? these are the things that will happen. If the object is at rest, it will remain at rest. In other words, if the object is not moving and there's no force acting on it, you don't disturb the object, or you don't push it, you don't pull it, it will not move. It will never move. Okay? And the other thing is, an object in motion will continue in motion in a constant speed in a straight line. So if the object is already moving and you don't push it, or you don't exert force on it, or you don't push it, you don't pull it, it will continue to move in the same manner. In other words, it will continue to move in the same speed and in the same direction in a straight line. Unless you give it a force, then it will change its direction. Okay, so this first law of motion is talking about what happens when there is no force. When there is no force, two things will happen. One, or two things will not happen. One, an object that is not moving will continue to not move. And two, an object that is already moving will continue to move in the same manner. In other words, it will continue to move in the same speed and the same direction, unless there is a force acting on it. Then it will change its movement, whether it slows down, moves faster, or change direction. Okay, so the first law is talking about what happens when there is no resultant force, when there is no force acting on the object. Right, so these are the things that I talked about. So the first law is saying that when there is no resultant force acting on a body, the body will continue doing whatever that it's doing. If it's at rest, it will remain at rest. If it's already moving, it will continue moving at constant speed in a straight line. So it just continues to move whatever it's doing. Number 4, see the picture on the right. The book is not moving. This is because the resultant force of the book is 0. All forces acting on the book are balanced. The weight of the book is acting downwards, and there is an equal force pushing on the book upwards. The upward force is the reaction of the table and balances the weight of the book. So what's happening here? So this is an example of Newton's first law of motion in action. So first, you need to realize when you put a book or an item on a table and it's not moving, there are two forces acting on it. The first force is the weight or the gravity pulling the book downwards. The second force is the force that is coming from the book in contact with the table. So when the book is in contact with the table is holding the book up. So there is an upward force, and this force is called a reaction force, or otherwise known as the normal force. Okay, so it has two names. Sometimes it's called the reaction force, sometimes it's called the reaction force. And these two forces are equal. So when two forces are equal, they balance out each other and there's no resultant force. Okay, and this is what the first law is talking about. If you don't have a result, so you do have forces here. The difference is there's no resultant force. These two forces are balanced. These two forces are equal to each other and they cancel out each other. There's no resultant force. When there's no resultant force, then the object will not move. The second example here, I'll read it for you first. See the picture on the right. The weight of the jet is balanced by the lift from the wings, so the aircraft flies at constant height. The air resistance encountered on moving forward is balanced by the thrust of the engines, so the velocity of the aircraft is constant. So in this second example, the aircraft is actually moving, and the forces acting on the aircraft, they are all balanced. In other words, they are all equal. You have an upward force that is called the lift force, pointing upwards, and then you have the weight of the aircraft pointing downwards. These two are equal, so they cancel out each other. And then you have the aircraft. There is a force forwards on the aircraft. This is called the thrust. And then there is a force backwards on the aircraft, which is called the drag or air resistance. There are two names for it. And the forward and backwards forces are equal, so they cancel out each other. So even though the forces, you have forces here, and in this case everywhere, but because they are balanced, there is no resultant force, and therefore the aircraft is moving, but moving at constant speed. Number 6, no resultant force does not mean that there are no forces acting on the object. It's just that all the forces are balanced. So if you see an object that is not moving at all, that does not mean it doesn't have any forces acting on it. In fact, there are forces acting on the object. It's just all these forces are balanced. They cancel out each other. The forces up is cancelled by the forces downwards. The forces to the left are all cancelled by the forces to the right. Okay, so if an object is not moving, it doesn't mean it doesn't have force. It might have forces acting on it. It's just that the forces are balanced. That's why it doesn't move. Same thing when the object is moving at constant speed. Now, so what happens when there is a force acting on the object, or the forces on the object are unbalanced? So one force is bigger than the other. So let's say the upward force is bigger than the downward force. When this happens, when the forces are unbalanced, there will be a resultant force. When there is a resultant force, what will happen? If the object is not moving and there is a resultant force acting on it, or there is a force, or you push it, the stationary object will begin to move. And if the object is already moving, what will happen? It will either stop, or it will move faster, or it will slow down, or it will change direction. So when there is an unbalanced force, or when there is a resultant force, that means that the motion of the object will change. So from not moving to moving, from slower to faster, or faster to slower, or from moving to from moving to stopping, or from going straight to going to the left. So when there is a resultant force, the motion of the object will change. And that is what the second law is talking about. So the first law is talking about what happens when there is no resultant force, or when there is no force at all. When there is no force at all, the object will keep doing whatever it's doing. If it's not moving, then it will continue to not move. If it's already moving, then it will move at constant speed. The second law is talking about what happens when there is a resultant force. When there is a resultant force, I'll read it for you. It's again a long statement. Newton's second law of motion states that the resultant force acting upon an object is equal to the product of the mass and the acceleration of the object. The direction of the force is the same as that of the object's acceleration. Now that's very long, okay? But the thing that you need to know is that whenever there is a resultant force, there will be acceleration, okay? And from this law, they figured out a formula or an equation for forces that relates forces to motion, and this is the law. This is the equation. Force is equal to mass times acceleration. F is equal to ma. So you have to remember this formula. Okay. So from the second law, so this formula is actually the second law. F is equal to ma. If you have a resultant force, then you will produce an acceleration, or in other words, the motion of the object will change. That's why you have acceleration. Okay, let's do an exercise or an example question to see how this formula is used in a question. Exercise 2, number 1. A trolley of mass 2 kilograms is pulled along a smooth surface with a constant force F as shown in the figure below. A, if the acceleration of the trolley is 1.5 meter per second square, what is the magnitude of F? And B, if the applied force is double, what will be the acceleration produced? Let's answer A first. So for A, let's write down the equation. Force is equal to mass. I'm sorry for my handwriting. I only have a mouse here to write things down, but bear with me. So F is equal to ma. Force is equal to mass times acceleration. The mass is 2 kilograms. That's the mass. And then the acceleration is 1.5. So 2 times 1.5, that is equal to 3. And then don't forget to write down the units every time, 3 newtons. Okay? So that's the answer for A. And then for B, if the applied force is double, what will be the acceleration produced? So the formula, again, we have to use the same formula. And this time it's asking if you double the force, what is the acceleration? So the force that we calculated before is 3 Newton. That means if you double 3 Newton, that is 6 Newton. So let's say the force is now double, 6 Newton. The mass stays the same because it's still the same trolley. And we want to find the acceleration this time. Okay, so you rearrange this equation. So that will be equal to 6 divided by 2 in order to find the acceleration. And 6 divided by 2, that is 3. Okay, and the answer is 3 meters per second square. So if you double the force, you will also double the acceleration. So the acceleration before was 1.5. Now the acceleration is 3. Okay, that makes sense. You know, if you push something twice as strong, then it will become faster, twice as faster, or the acceleration is twice as larger. The second example, you have a sports car of mass 900 kilograms, which can accelerate at 2.5 meters per second square away from the traffic lights. So is that fast? I don't know. What is the resultant force needed to give it this acceleration? Again, we use the same formula. Force is equal to mass times acceleration. And you want to figure out the force. And the mass is 900 kilogram. So if you have a mass of 900 kilogram and then you want it to have a acceleration of 2.5 meters per second square, what is the force that you need? So you have to calculate that. 2,250 Newton. So you need 2,050 Newton in order to accelerate this sports car to 2.5 meters per second. So here is a summary. So hopefully all of that is not confusing for you. And here is the summary of the first two laws of motion. Okay, there are three laws. We looked at two just now. So the first law and the second law. The first law is talking about what happens when there is no force and there's no resultant force. When there's no resultant force, that means the forces are balanced, and that means there's no change in motion. What does the no change in motion mean? If it's not moving, then it will continue to not move. If it's already moving, then it will continue to move, but in a constant speed. Okay, so in other words, when there is no resultant force, the object does not accelerate. The speed is constant. So if the speed is 10 meters per second, that means the speed is the same 10 meters per second at all times. If it's not moving, then that means the speed is 0 meters per second. So the speed does not change. So it's 0 meters per second at all times. So it doesn't accelerate. It doesn't speed up. It doesn't slow down. And the second Newton's second law is talking about when there is an unbalanced force or when there is a resultant force, what will happen? So when there is a resultant force, the motion will change. In other words, it will speed up, it will slow down, or it will change direction, or we will stop, or it will begin to move. Okay, there is a change in motion of the object. And whenever there is a change in motion, usually that means there is acceleration. What is causing a change in motion? Acceleration or deceleration, depending on how you think about it. And that is the end of the lesson. So we have gone through the basics of forces. We talked about what is a resultant force and how to roughly calculate the resultant force. We talked about the first law of motion, and we talked about the second law of motion and how to use the second law of motion, F is equal to m times a, in your calculation. So basically, that wraps up this video lesson. The next video lesson, we will talk about the third law of motion, and that will be next week. So I'll stop there for today. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh. I'll see you next week.